Hello, today I'm gonna solve number 23, merge k sorted list. Let's read the problem. Merge k sorted linked list and return it as one sorted list. Analyze and describe its complexity. Let's see the example. Input has three linked lists, 145, 134, 26. The output would be 1123, 4456. How can I get a single sorted linked list? Let me explain my solution. Okay, let's see the diagram. To get the sorted linked list, we have to compare the list node and list 1, 2, 3. At the beginning, we are going to compare the first three nodes in list 1 to 3. And we can choose the first element, number 1. And then we move the list 1's starting point to number 4, because the number 1 is located in result linked list. And then we compare 4, 1, 2, and number 1 is chosen as minimum value. And then the starting point of list 2 is moved to number 3. And then the number 4, 3, 2 nodes are compared, and the number 2 is chosen as the minimum value. List 3 is also moved to number 6. In this way, we can do the sorting operation up to the last node remaining in three linked lists. It's a very simple and straightforward way. Let's see the code. At the beginning, the min index is initialized with -1. Min index is used to store the minimum list index among the list 1 to 3. Using for loop, we are finding the minimum value node by comparing the list value with a previous minimum value. So the smallest value index is updated in min index. If we had valid min index value, first we should update the head pointer. This is done once at the beginning. Head pointer is the starting point of result linked list, and we should update the prev next pointer with the current min index node. And the prev is the tail pointer of linked list storing the result. So this line is the process of adding min value at the tail node, and we move the prev pointer to the next position. We also should update the list pointer of which node has been added on result list just before. In our case, which is when prev pointer having no value at the beginning. In this case, just update the prev pointer with the current min index node because there is no next pointer of prev pointer. While we continue until min index has -1 value. This means that all list node has been added in the result list. And lastly, we need to update the prev next pointer as null pointer and return head pointer, which is the starting point of result list. This code has 480 millisecond runtime. That is very slow performance. So what's the problem in this code? My code is always iterate three linked lists, so it has t multiply 3n time complexity, which would be on performance. I compared the performance of my code against the solution provided in LeetCode.com. This solution provides the n log t performance, which is faster than the tn performance. Sorry, I took a mistake. Tn is not same as on time complexity. The reason of log t is that pair of list nodes are combined into one sorted linked list. This is the concept used in merge sort, having the time complexity of n log n. So as you can see, this algorithm has n of sigma I from 1 to log t, which would be n log t time complexity, much faster than my previous solution. So I implemented this solution using C++, referring the original Python solution. The code is using while loop to iterate a pair linked list. Interval is increased exponentially. An internal for loop, having index I starting from 0. It's a little bit tricky part. Thereby the list I and the list I plus interval are the pair linked lists that should be merged. And the merge to list function merge two linked lists into the first one with on time complexity. This code performs faster than 98.72%. Thank you for watching. See you next time. Bye bye.